Welcome to our lesson on the exponent laws. Today's learning target, we're going to look at 3 of the 6 exponent laws that we'll be learning this year. And today's learning target specifically is I can use the 3 exponent laws to solve problems. And the 3 we're going to look at are as follows. So the first exponent law we're going to look at is product of powers. And don't worry, I'm going to go into how we use each of these exponent laws in just a moment here. The second exponent law we're going to look at is quotient of powers. And the third exponent law we're going to look at is called power of a power, or power of powers. So we're going to look at 3 examples of each of these exponent laws in just a moment. We're going to start with the product of powers, followed by the quotient of powers, and then we're going to end with the power of powers. And again, our learning target that we're exploring is I can use the 3 exponent laws to solve problems. So our first exponent law that we're going to take a look at is the product of powers. Product of powers, notice how I have 2 numbers. Each of them involves an exponent. Those are our powers. And I have a product, meaning I'm multiplying 2 values by one another. That's where our product comes in. So I have a product that I'm looking for, and I have numbers that involve exponents or powers. In this example, I have a to the power of m times a to the power of n. According to this equation, a to the power of n times a to the power of n is equal to a to the power of m plus n. So whatever value this is becomes a single base of a. This is known as the base, whereas this is the exponent. When I multiply numbers that have the same base, we can combine them into a single base. And when I'm looking at the exponents, I add the exponents. Notice how the operation there is an addition sign. So let's look at an actual example involving real numbers here. So if I have 2 to the power of 3, or 2 cubed, and I multiply this by 2 to the power of 5, notice how I have the same bases, both have a base of 2, but I have different exponents. This one has an exponent of 3, here I have an exponent of 5. Now before I get into using this part of the equation, let's just think about what we're actually saying here when we say 2 cubed times 2 to the power of 5. I can use repeated multiplication in order to show what is happening here. So if I have 2 cubed, this is the same thing as saying 2 times 2 times 2. And if I multiply that by 2 to the power of 5, then I'm multiplying that by 2 times 2 times 2 times 2 times 2. Remember that all these exponents are doing is showing repeated multiplication. And so if I multiply repeated multiplication, then I'm really just multiplying or repeating the multiplication by however many times my exponent tells me to. So if I look at how many times I'm multiplying 2 here, well, I'm going 2 times 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 2. Remember, these brackets indicate that we're multiplying these values by one another. So if I count the number of 2's that I'm multiplying here, I have 1, 2, 3, 4, 5, 6, 7, 8 2's that I'm multiplying by one another. Another way I could express that is saying 2 to the power of 8. And so that's what our shortcut, well, not the shortcut, but what our power law is actually showing us. This product of powers is telling us that if I have repeated multiplication shown as exponents, then instead of writing out repeated multiplication like I did here, I can instead show it like this. And I'm just going to rewrite the actual problem here. I can instead show it like this. 2 cubed times 2 to the power of 5 is equal to 2 to the power of 3 plus 5. Remember, these are my exponents, 3 plus 5, which is equal to 2 to the power of 8. So this is our first exponent law that we're looking at, the product of powers. We can express this as our final answer, 2 to the power of 8, or you can go ahead and you could expand that. 2 to the power of 8 is equal to 256, and that would be our final numerical value. So that's our product of powers. Next, we're going to be looking at our quotient of powers. So a quotient, just like if we have the opposite operation of a product, our quotient is when we're dividing two values. And so when we had the product of powers, we were multiplying, but here we're dividing. I have a to the power of m divided by a to the power of n, and this is equal to a to the power of m subtract n. So let's think of another example. Let's say we have 2 to the power of 4, and we divide that by 2 squared. I'm first going to show this using repeated multiplication, and then we'll look at what our power law says. So if I have 2 to the power of 4 in repeated multiplication, this is 2 times 2 times 2 times 2, divided by 2 times 2, or 2 squared. Now, if I have repeated multiplication, and on the bottom here I have division, remember that whenever we're simplifying a quotient, I can cancel out like factors, or the same factor. This leaves me with 2 times 2, or 2 squared, also known as 4. Now, let's keep in mind what we did here with the repeated multiplication, but let's examine what our law is telling us we can instead do. If I have 2 to the power of 4 divided by 2 to the power of 2, I can instead write this as 2 to the power of 4 subtract 2, which is 2 to the power of 4 minus 2 is 2, or 2 squared is 4. So instead of writing out my repeated multiplication and canceling out the factors that can be canceled out, I can instead go ahead and subtract my exponents as long as my base is the same. And that's what happened with the last problem too with my product of powers, is I had to have the same base. In my next example we're going to look at, we're going to examine our third exponent law for the day, and that is power of powers. So with power of powers, notice how this time I have a single base, but I have two different exponents. And I'm raising one exponent to the other. So I'm raising one power to another power. When I raise one power to another power, I'm able to multiply my exponents. And that's what this operation is showing, is multiplying exponents. And so let's look at an example of 2 to the power of 2 to the power of 3. And just like we did in the previous examples, we're going to first show this using repeated multiplication, just so we can see conceptually what's happening here. So remember, an exponent shows repeated multiplication. So if I have 2 squared, we know that that's going to be 2 times 2. But I have another exponent, and again, exponents show repeated multiplication. And so this tells me that I need to say 2 squared 3 times. So I have 2 times 2, which means I need another 2 times 2. And if I have a power of 3, that means I'm multiplying it 3 times. So 1, 2, 3, 2 squareds. if I have 3 2 squareds, then what do I really have in terms of my repeated multiplication? Well, I have 1, 2, 3, 4, 5, 6. That's 2 to the power of 6. Now, remember, we can, instead of showing repeated multiplication, we can show this using one of my exponent laws. And we're going to show this using my power of a power. So instead of saying 2 times 2 times 2 times 2 times 2 times 2, I can say 2 times 2 times 3. This dot is the same thing as a multiplication sign. This shows us 2 to the power of 6, or 64. If we go back to our learning targets, I can use the 3 exponent laws to solve problems. The first one we looked at was our product of power. And remember, the product of power is when I am multiplying, or a product, values that have exponents or powers. My quotient of powers was when I was finding the quotient of numbers that have exponents or powers. And my third exponent law was my power of powers. So when I have an exponent raised to another exponent, or a power raised to another power. I'd encourage you to go through the video again if you need to. As you go through the video, you can pause, you can rewind, you can slow it down, but the important thing is that you're able to review at your own pace.